Hey guys, what's up? And today we are going to be doing the problem keys and rooms. This problem states that there are n rooms, right? So we are given like a list of rooms. So that's basically the count of those rooms is n, and we have rooms labeled from 0 to n minus 1. So n minus 1 is due to the fact that we are indexing from 0 and not from 1. If we were indexing from 1, we would take from 1 to n. So all the rooms are logged except for room 0, and our goal is to visit all the rooms. However, we cannot enter a logged room without having its key, okay? So when we visit a room, right, we might find set of distinct keys in it. So it says we might. It's not guaranteed. We might. Each key has a number on it denoting which room it unlocks, and you can take all of them with you to unlock the other rooms. Cool. So we are given an array rooms where rooms are is the set of keys that you can, well, we are not given array, we are given a list. Clearly, at least in C sharp, we are given a list. So that you can obtain if you visited room I, return true if you can visit all the rooms or false otherwise. Cool? Very cool. I'll show you a little bit example with this example one. So this is room 0, right? Where the key 1 is. We visit room 0, pick up key 1. We then visit room 1, pick up key 2. We then visit room 2 and pick up key 3, right? So go down, and this example says pick 1 and 3. 1 and 3, well, if we go 1 and 3, then we can go room 1, we pick 3, 0, and 1. We could then go to room 3, we pick 0 again, but we never picked up key for room 2, so that's why this example is false, right? Nice, nice, nice. So we established this. So this seems like a little bit like a graph structure. So if we can have like a graph, can we do this problem? Well, pretty much we can do a DFS, right? And that should be enough. So how do you make a graph? Well, see, we are given a list of lists. That is itself a graph. We are given a graph structure. Cool. So now, what do we want to do? Well, say I visited one room. I do not want to visit it again. The reason I don't want to visit it again is I already took all the keys from it, right? Suppose that we have example where like there's like key 1 in room 0, which takes me to like this room, which has like 2, 3. So room 1 has keys 2 and 3, and the room 2 has key 1, and room 3 also has key 1, right? So if I visited 2, 3, I don't want to visit 2, 3 again, because if I do, then it's an infinite loop. Then that will never work, okay? So there's some sort of visited notion we need to keep a track that if I visited a room, I don't want to visit it again. That can be solved basically with a bool array of visited, which just becomes like rooms.count, which is the n basically. So that is also something we established, which is good. We are one step forward. Now, it is given that you can DFS only for the room 0 because that is the only room that is unlocked. Okay, so I can just do room DFS 0. Now keep in mind, this is a connected graph problem, right? There should not be any disjoint sets basically. If there's a disjoint set, that means you cannot really visit all the rooms. So everything is connected. So doing just one DFS on one node should be good enough for us to traverse through every single thing, right? So with that in mind, we just do a DFS on room 0. Once we do a DFS on room 0, what we are going to do is mark it as visited, and then all the keys contained in this room, we are going to be greedy. We are directly going to go to those rooms because we know if we have a key for it, we can open that room. Right? Make sense? So I collected one like key 1 from our example. I went to room 1. In room 1, I collected key 2. I went to room 2. With room 2, I collected key 1. They came back to room 1. But here, nothing's really gonna happen because I already visited it. So now I'm just gonna be like, okay, what about the 3? So I'm just gonna take key 3, go back to room 3, say it's gonna take back me to room 1, and it's gonna be like, okay, this is done. So now what I'm gonna do in my main method is say that if I find anything that is not marked as true, that means that node was never visited, that room was never visited. So I can return false. So guys, I hope you like this problem. This was the whole problem. And that's it. Let's discuss the time complexity. So with a DFS, right? Justify DFS, that means that if there are M, which is the not M, let's say N is given to us. So N are the number of rooms, and let's say average size of a list is M, then complexity straight away comes as N times M, right? Say if there were N rooms and each list also had like N neighbors, um, on approximate it, then it's gonna become like N squared, which stands with our DFS definition, right? Which is exactly correct. So that is something that is correct. And then we have visited, we just created a visited, right? So that is only N. So space complexity is only O of N, whereas time complexity of O of N squared. So I hope this helps you guys, and this is like the complete solution of this problem. And I'll see you guys in the next video.